So first, this is a kind of just a bullet point overview of what the heck Pandas is. So basically what Pandas does is it makes it easy to get some data into Python that might be in an Excel spreadsheet or a CSV file or a JSON file or some other file format. It has tools for reading in a whole bunch of different file types and also exporting data to lots of other file types. So in one unified place, it gives you the ability to easily read in and export data. And then once you have the data read in, you can easily manipulate it in a lot of powerful ways. And when I say easily, it takes a little while to understand what the documentation says, but then when you write the line to do the manipulation you need to do, you may be surprised at how short, concise, and succinct it is. For example, when we were writing up the solutions for the homework, we were often shocked by how short they are. So you'll be happy to see that. So basically, Pandas is a tool that lets you manipulate statistical sort of data that kind of looks like pages in an Excel spreadsheet. It's similar to what R is very good at. It provides a very powerful data frame, which is kind of like a spreadsheet, but in a computer programming language. Pandas itself, this library, which, by the way, you guys should really appreciate that it exists, because when I tried to do statistical type stuff in Python around 2007, 2008, 2009, for Sage and other reasons, it was incredibly frustrating. Like, basically there was almost nothing, and what was there was really bad. And your main tool was to use an interface to R or something to actually do any statistical stuff, or use some not so good stuff in SciPy. But the situation today is dramatically better, as you'll see. There's a huge amount of momentum behind these projects. They're pretty polished at this point. There's books about them. They're all beautifully open sourced and developed and used by lots of companies and so on. And really, Python itself has kind of really taken off for data science and data manipulation. So just to emphasize, Pandas itself doesn't do all this extra modeling and machine learning. It just provides the tool that lets you figure out what data you want to do that on. So it's like a key step in the pipeline of getting data from somewhere, manipulating it, and then maybe modeling it in some other way. So it just kind of fits into that. And there are other tools that are also easily usable from Python and Sage, which are available. So I'm going to click on this link, which is about highlights of what Pandas does. Just show you this for a little bit. So Pandas has a fast and efficient data frame object for manipulating arrays of data. And it's extremely fast and concise. And as I mentioned before, you can read and write CSV files, text files, Excel files, SQL databases, HDF5 format data, etc. There's lots of other clever stuff involving slicing and dicing and indexing your data, etc. Merging data, joining data. You have some data here and some data there, and you want to put them together in a certain way, and it's like 2 lines of code, and it does it. Lots and lots of nice stuff for working with time series. So you have a bunch of prices of stock or something, and you have the data for every minute, but you really wish you had the data for every 5 minutes, or you wanted to change the time zone in which the data is displayed, or anything like that. It's just like super good at that sort of thing. Another thing is it's very highly optimized. A lot of the code, they've rewritten it in Python to make it fast, or in C. So when you use the library, it's just automatically really fast when you use the functions that are there. And it is widely used, which is an important feature of a library. Okay, so there's a page in the official Pandas documentation called Pandas in 10 minutes. And I wish I could show you everything about that whole page in 10 minutes, but I think it was Pandas in 10 minutes at some point in time, maybe like 4 or 5 years ago. Because now it's like Pandas in maybe 3 or 4 hours. But I'll show you just a little bit of it. So Pandas in 10 minutes. So the 10-minute guide to Pandas. So I'm sure this is all true at some point in time. So first, there are some conventions they make which are assumed throughout the rest of the code. And that is that they've imported the Pandas library, Pandas is just a Python library. It's completely free and open source. I think BSD licensed. You can look at everything about it on GitHub, etc. So they import it as PD. There's another library, NumPy, which we've hardly done anything with, but is very important and foundational in Python. NumPy is I've just mentioned it a few times, but it's a library for kind of numerical arrays and so on. And Matplotlib, which is a library for doing plotting in Python, which was originally inspired very much by MATLAB and has got very good over the last decade. So they import these three in Sage, and so I went through and kind of redone this tutorial, but in Sage. So 10 minutes. There are some other things, so let me just zoom in a little bit. Wow, my laptop is buzzing. That's scary. Okay, so this version thing isn't important. I've installed the latest version of Pandas so that it's available. It was a little bit behind, but in SMC it's now the latest version. The first 3 lines are exactly what was in that tutorial. And then there's one other thing they suggest doing if you want to draw graphics, just so they look pretty, is import Matplotlib and then set the style to ggplot, which again makes the graphics look very similar to how they look in R. So Python is catching up with R and maybe getting way beyond it in certain ways. There are 2 lines, though, that are special to Sage, which I've added here. One is default mode Python. What that does is makes it so that the Sage preparser isn't run. So when you type an integer like 5, it's just the Python int 5. It won't be the Sage integer 5. In particular, after running this code, and because I have %auto there, by the way, anytime you restart this worksheet or just open it for the first time, that code will get run. But just to, if I type 2/3, this is division of Python ints, so it's floor division, and so it returns 0, as you can see here. The other thing is typeset mode true.
So
yes?
So it's like you're setting default mode for like all the cells
Yep.
to be Python?
What default mode does is it makes it so that that mode it's exactly as if you put %Python at the top of every cell ever after. Okay. Another thing is typeset mode true. What that does is every time you would normally print, it's as if you just did show. You probably wish you knew about that before. So you can get it from the little modes thing on the left, typeset output, and that'll just insert typeset mode true. What that will do in the context of Pandas is that for data frames, Pandas has a nice HTML table output, and it will automatically use that every time. Okay, and that's why this 0 is in the middle, nicely typeset. So, if you do pi to the power of e now, it always, no, because it's doing exclusive OR, because I've done default mode Python, but I have to do double asterisks, so it's all just normal Python. But notice it's still Sage, and it still typesets things like this. All right, so now I'm going to show you just a little tiny bit of the very beginnings, probably around 10 minutes, which will be just a little tiny bit of the 10-minute guide of how to use Pandas. So Pandas has 2 really important things. One is called a series, and here's how you make a series, just give a bunch of numbers. And the other is called a data frame, and we'll see that in a moment. So here's a series. We just define it. And this one's just indexed by the numbers from 0 up to 5. And you can have, well, you can see that the values are all of the same type. They're all float 64. And here's another useful thing. You can make a range of dates. So this is just the kind of sort of really convenient stuff that Pandas has in it. So you say, starting on that day, make 6 dates. And there they are. And they're actually of a special date time type. And you can say the frequency. So just so you understand, there's one function you'll be able to look up in the documentation, and it will let you say, starting at this point in time, give me a whole bunch of date time objects in this case, every day, but you can have it every hour, every minute, whatever. So it's an extremely powerful little function that will give you equally spaced points in time. Presumably, it takes into account things like leap years and so on, I assume. I don't actually know, but I'd be shocked if it didn't, because that's like the obvious problem you need to solve if you're going to say, start at this time, do something. Actually, for fun, didn't we just have a 2000, is it a leap year?
Yes.
Yes, so let's just see what happens if we do this. See whether it properly takes into account February. So this year, boom, 27th, let's see what happens. Yes, and now let's try it again, but for next year, which is definitely not a leap year. It does. So that's the sort of little thing where if you wanted to write this yourself, it would be really tedious. It's really good that there's a function that does that already. All right. Okay, so now we're going to make our first data frame. And we'll stare at this for a bit. So in this pandas in 10 minutes thing, all of the data is basically just random. It's not some big example involving some measurements of irises from the 1850s or something like that, which is involved in one of the homework problems. It's just completely random data. The idea here is just that you can focus on the kind of core underlying objects that Pandas provides and not get distracted by some particular data analysis problem. We will look at examples, especially in your homework, involving actual interesting data. But here's what you do. So this is an extremely important command. It creates a data frame. So if that kind of looks like an Excel spreadsheet to you, that's okay, it should, because these really are like a computer way, or not computer, but a Python way. And again, R also has this idea of data frames, so it's a statistics software way of modeling the same kind of idea as a spreadsheet. Although you don't have like formulas in the cells. So it's a completely different programming model. Spreadsheets are basically a reactive programming model where you make changes somewhere and things get evaluated automatically into some consistent state. Here, you're just modeling the data part of a spreadsheet, but you still use Python to do all the programming and so on. So what this does is, right here it generates this np random rand n. np stands for numpy. Random is a module inside of numpy for generating random stuff. So if I tab complete on np.random, actually let's start a little to the left. Oops, I guess I don't have zoom. If I do np.tab, this shows you a large amount of different functionality that's in NumPy. So NumPy is some huge, super powerful, very polished library. And then inside of it, there's a module called random, which lets you generate all kinds of random things, as you can see here. So it itself is quite sophisticated. And then inside of random, one of the functions is rand n, which I think makes so see that says return a sample from the standard normal distribution. So what this does is it generates a bunch of numbers that are normally distributed. But it doesn't just generate like a list of those numbers. It generates them and puts them in an n-dimensional array. And in this case, because we've given two inputs, 6 and 4, it gives us back a 6 by 4 array. But NumPy is equally adept at working with any number of dimensions. What if we wanted a 6 by 4 by 2 array? You just put another parameter in there. And that's going to give us, this is a 3-dimensional array, an array that kind of goes off in 3 dimensions. So you imagine a 6 by 4 array and then another one sitting next to it. Yes?
I guess this is a Python question, but are lists distinguished from arrays at all? Or
Yes. So in NumPy, there's a data type called an array. It's kind of like in Sage, there was a vector data type. And it's a completely different data type than a list. A Python list is a bunch of Python objects. Each one can be absolutely anything, an arbitrary Python object. A NumPy array, all elements of that array will have the same data type. And that data type, there's like an explicit list of supported data types, like 32-bit int, 64-bit float, etc., 128-bit complex. And then one of the special data types is object, and then you can put anything in it. Okay, and the operations on a NumPy array are different than the operations on a Python list. There's all kinds of really cool stuff you can do with NumPy arrays. So, and then to be a little simpler, here's a one-dimensional NumPy array, which is 6 entries in it. So that really is just kind of, it's a collection, or I mean, it's in order 6 values. Okay? And so if you want, and notice these numbers, I mean, you can't really tell with your eyes, but they're normally distributed. So that makes a lot of sense if you're generating data for some application. Okay, so I've just explained this part. You should understand np.random.randn64. If you wanted some different distribution, where it says rand n, you put something else there. Okay, index equals dates. Remember above we made this date range object. We actually played around and made a bunch of them, so I better reevaluate this to make sure it's the right one. So what that is going to do, that's basically the labels on the rows of our spreadsheet, of our data frame. So it's the index. And when you do this data frame object, you get it back. It's some like object. You can do a lot of stuff with it. One of the things you can do is df square brackets. And then you can give a date in order to index into it. And that's why it says index equals dates. Okay, so here it is. And now here, list ABCD. That's just the way in Python to, let me put a print explicitly so that it doesn't. If you say list of anything that can be iterated over in Python, Python will iterate over it and make a list out of that thing. So when he writes list of ABCD, that's just a shorthand for making this list right here. We could have equivalently put explicitly the column headings. Okay? So that's all that is. And then columns equals, we're explicitly saying we want the headings of the columns to be as given. Okay, so it's really like when you call data frame, you're kind of thinking about the same thing you'd be thinking about if you were going to make a really simple Excel spreadsheet. It has some headings, it has some data that's in it, maybe you have some labels for the rows. Okay? And the first input, of course, which I explained, that's the actual data that you'll have in there. And as we'll see in a minute, you can also have data that isn't numerical inside of this. And you can do an insanely amazing amount of stuff with these things. Okay, so let's make it. It should look a little different when I evaluate because it's going to be random again. Notice that all the entries change. Like every time I evaluate, they all change. It's randomly generating all the entries, normally distributed. Okay, and there's our df. That's a data frame. So if I do type of df, it's a pandas data frame. And if I do df.tab, you'll see that there's a whole bunch of stuff you can do with a data frame. Not to jump too far ahead, but for example, df.plot, right there. If you do df.plot, then do tab again, .tab again, then you see different sorts of plots that you can draw associated to a data frame. So you can make things like bar charts, density plots, histograms, pie charts, scatter plots, etc. And these all look really pretty. And similar to how they would look in R. Okay, so let me get rid of that. Okay, here's another example of making a data frame. But here, we don't explicitly specify the index. Notice the input here is just an arbitrary kind of Python dictionary. And the things on the right, that is the entries that are going to go in the columns, they're just all kinds of different things. There's a number in one case. There's a timestamp. There's a series. That was like the thing we did at the very beginning. There's a NumPy array of 32-bit integers. There's some strings, which allow you to categorize stuff. And there's a single string. And there's a whole bunch of rules in Pandas about how it will deal with these values to make them all fit into a table, or a data frame as it's called. So notice what happened. When we gave a single number, it just repeated that number so that everything was filled in. When we gave a timestamp, it just repeated it. So when you give a single thing, it just repeats it. For the series, it was just a bunch of copies of one. And then the array, it put all the entries there. Actually, I want to make this 1, 2, 3, 4. So you can see it puts all the entries of the array here. the words go here. And so you can have words inside of the table. And those will work. Those are extremely important in practice. Yes?
Is there a default data type for numerical arrays?
I think it figures it out based on the input. So that's kind of a NumPy question, but let's look at what happens. We just take an array of Python ints, remember, because I turned off all the Sage pre-parsing business. Then, let's see, type of this maybe. NumPy array. I'll call it A. There's a method, I think, .dtype that will tell us the type. .dtype. Int 64. So it looked at the input numbers and then it made a 64-bit int out of them, or it decided that was sort of probably the most likely thing you'd want to use. That's not necessarily the case. Like if you have a bunch of Python integers, they might not all fit in 64 bits, and then I'm sure it would do something else. I don't know what. I hope it would do something else. Let's see what happens. So if I do 4 to the power of 5,000, that's definitely not a 32-bit or 64-bit int. So let's see what it does. So it's a really big thing. And then here, it's an object. So it could not fit them all in 64-bit ints, and so it decided to just make the data type object, which is arbitrary Python objects. So in this case, arbitrary precision Python objects. You have to watch out because just the size of the actual numbers when you're making this array determines the data type, unless you're explicit about that. And then you can silently have overflow that happens. So if you start out with your entries small and do a certain sequence of operations, the result could be 1,000 times faster and 1,000 times more wrong than if you are explicit about the data types. So watch out. In any case, here's our little table that we got, or data frame that we got by giving explicitly these columns. And you could give, what's your name again?
Jake.
Jake. So you don't have to call them just a letter. It could be Jake, let's see, Jake's column. Obviously I can't do that, but I can do that. What did I do wrong? Oh, the quote's missing. Okay, so see what you can make Jake's column. And apparently it sorts them in alphabetical order. Or the dictionary just, I mean, there's no real order in a dictionary, so. Okay, and here it'll show us the data types it happens to have chose. So you got date time 64. Head shows, let's see. That just shows the first few inches. It's kind of weird to switch. Often when you create a data frame, it will have an enormous number of entries, right? Like in real life, you can have millions of rows in these things. And so head just shows you the first few. And there's probably a command tail that shows you the last few. Yes, Jake?
So the categorical method that, or function that turns it in strings into categories?
Yeah, category is just like, it's just a string. I mean, it's basically just a string. So
that's one of the types supported.
Yep, they have a type called category. So like in practice, common categories are like gender, male or female, car manufacturer. You'll see that in one of the examples. So it's you end up with one of the columns in your data frame is the car manufacturer, and then you can say something like, give me the average of blah, where the car manufacturer is blah, stuff like that. And it's like one line, and you get all these sort of really complicated, cool queries that are really natural to make. I mean, honestly, all I can tell you is that it's really, really awesome to use Pandas, and you have to put in a few hours to start getting your head around it, because it's just opaque and confusing until you do. And if you look like online, nobody claims Pandas is like really easy to learn. In fact, steep learning curve is sometimes used to describe it, but it is well worth it, I think. Oh, yep, here's tail to get the last few entries. Index, that just tells you what the entries are in the left column, that everything's being indexed by. But let me show you, you can grab stuff by entries in the index. So I think with df I could go, give me the entry that corresponds to that date. Nope. I might have to, I think I have to give the actual date. So maybe df.index1. Nope. What the hell? I don't know what I'm doing. I know that I can do this. Nope. Okay, I'm just trying to prove to you that the learning curve is steep. Success. Okay, so learning curve is steep. I know you can do this though. I've done that a lot. You can slice like that, so if you do like :3, it gives you the first 3 things. Okay, here's columns, the actual numbers that are in the data frame. Here's a really cool one, describe. So let me just print out the whole data frame again. Remember, this was the random one we made at the top. So whenever you have any data frame at all with anything in it, you can say that data frame.describe, open close parentheses. It gives you back another data frame that just gives you a bunch of summary statistics about each column. Like what's the biggest value, what's the smallest value, what's the mean, what's the standard deviation, etc. And so let's try it out on this particular example. And it's going to be different because I'm doing the example again. So look, so it gives you the number of entries, the mean, the standard deviation, the min, the max, etc. So it just gives you some summary statistics. And you can call it on anything. Like we can even do that with df2, the second data frame we made with all kinds of ridiculous stuff in it. See? I guess it ignores some of the columns that it doesn't make any sense to compute these statistics about. For example, Jake's column isn't listed here. But if I remember correctly, that was part of the data frame. Yep. So I guess it doesn't make sense to compute the mean and standard deviation of a bunch of dates, right? But as long as it makes sense, it'll do it and give you that. Okay. This T gives you the transpose. So that changes all the indexes into column headings and all the column headings into the index. So we could also do that with df2 if we wanted. Whoops. So it looks like that. Okay, so let's see. Again, I want to pull up df. So what dfa does, remember there was that series thing at the very, very beginning, the very first thing I showed you. It's a collection of values and they're indexed in some way. And in the default, they were just indexed by 0, 1, 2, 3. You can take any column of your data frame and you just do square brackets in the name of the column. And what it does is it will make a series, which is not a data frame, it's just a list of values, not a list, but it's a list, not in the sense of Python list, but a list of values, and then whatever the index is. So it's like a mapping from the index to the corresponding value. So if you do dfa, it gives us that A column, and then it remembers the corresponding dates, like the index into that series. Okay? And if we did this for D, it would do the same thing. Remembers those. So let's look at df2 for fun. What will happen if I do df2 square brackets Jake's column? What's this going to give us? It'll give us, what do you guess? I mean, you don't know, but what do you think it should do? It's going to give us a series, because that's what happens when you do this. A series is by definition something with an index and then the corresponding values. So what do you think we're going to get from that? How many things will be there? 4. And they'll all be the same date. And then they'll have 0, 1, 2, 3 as the index. Okay, so let's just see if I'm right and you're right. Yep, so that's great. And then if we were to do, say, E, what should happen if we do df square brackets in quotes E? We're going to get a series, which is indexed by 0, 1, 2, 3. And the values in the series are test, train, which are categorical values. And there they are. Okay. All right. And they have a shorthand. You can also use dot to index. So instead of df2, it's kind of a lot of work to write that out. You can also do this. See? It would be hard to do dot Jake's column because obviously it's not a valid identifier. I already showed you the slicing. Okay, so There's a lot of other stuff here. We've already been looking at this for far more than 10 minutes, and we've got through about 15% of this page, 10 minutes to Pandas. So let me just give you a sense. How far have we got? So the thing we just got to is right here. So it's about, I don't know, 20% of the way through this one tutorial. So there's a lot more to see. There's just lots and lots of other stuff about how you select data. There's cool stuff like this. Like, give me every row where the entry in that particular column is positive. Like, look at how simple that is. It gives you back a new data frame, which is characterized by some condition. And that is super powerful. You just take any data frame, and you say data frame square brackets, and you give a little logical condition. Like, give me only the positive values, only the negative values, only the values bigger than 10, only the values that equal a certain number. And then it'll give you back the kind of data frame you extract from the original data frame with that property. So just to show you one thing. Okay, and like if you had timestamps, you could use this to say, give me everything which is between a given range of times. So it's actually often very close to the sort of queries that you would do to a database, but it's all very, very fast in memory and expressive. Okay.
So is that saying that each entry in A needs to be positive?
Yep.
Take that row?
Yep. So it takes exactly, this thing df will have lots of, well, let's just do it on our df. Here's our df. Notice 2 of the rows are negative. If I do this, it's going to give me back a data frame with how many rows? 4, not counting the headings. And they're only the ones that are positive. So like, how would you do that in Excel? And then do something with that? You could do it, but it would start getting ugly, right? And this is really, like, I hardly typed anything. And you can see how to generalize this a lot. So really, really useful. Okay, I'm going to stop with this worksheet. I'm going to show you 1 second of the graphics. And then I want you to just play around with Pandas for about 10 minutes. So there exist graphics. And I'll show you the 1 minute of graphics. So look, graphics. I just did dot plot on something. More graphics. Look how pretty they are. More graphics. It's kind of similar. Look at that. See? Like, that's like how much code you write, and you get something like this. Or like that. Like stacked charts. Frequency histograms that look really pretty. Like that. Other frequency histograms and things that I don't quite know how to get to work yet. These things, I'm not a statistician. These look pretty neat. It's really easy to make scatter plots. And scatter plots where the size of the dot is a function of what you're plotting. And then something called hex bins. I don't really know anything about those, but they look really pretty. See? Kind of looks like some game, pie charts, etc. Okay, so there's 10 minutes left, and I just want you to try anything out, maybe look at the homework, try out a few examples of this. It's all in the shared project or in your project. Just try using Pandas a little bit, okay?